Welcome back as we now proceed to conduct electrical tests. The main test instrument to be used in this procedure is the mega-ohm meter with a 500-volt capacity. Electrical tests comprise three separate procedures, namely continuity of windings, winding insulation to earth, insulation between windings. In preparation for testing, the terminal box cover is removed and any bridge pieces removed. Test number 1 is to check for continuity of windings. This is done on the ohms scale of the mega. On your report sheet, make a sketch of the terminal positions and call the top left terminal A1. Now connect the clipped lead to terminal A1 and with the other lead probe the terminals until a reading is shown. Note the position and the value of the reading. Call the looped termination A2. Move the clipped lead to the next terminal, calling this B1. Again, probe the remaining terminals until a reading is found. This is B2 position. Again, note the connection and the reading on your report. Move the clip to the last position, C1, and measure the value, noting it on your report. The readings can now be analyzed to establish that the motor is balanced. A balanced motor will show resistance readings on all three phase coils at the same value. If readings vary by more than 5%, then the motor is considered imbalanced. The next test checks the insulation to earth of each phase winding or coil. In this test, the mega-ohm scale is selected. Connect one of the mega leads solidly to any good earth point on the motor body. Take readings, beginning at position A1 on the terminal block. Record the values at every terminal. When each terminal has been checked and recorded, the readings must be analyzed. A good or healthy motor will yield readings of infinity or above 0.5 mega-ohms on each terminal. If readings are below 0.5 mega-ohms, then the motor is unsafe. The cause is often related to dampness in the stator. We shall discuss methods of drying a motor shortly. Electric test number 3 is for insulation between windings or conductors. Again, we select the mega-ohm scale. Begin by clipping one lead to terminal A1, the other to terminal B1. Take a reading and record it on your test report sheet. Move the B1 lead across to the C1 position and take the next reading. Now move the lead off A1 and clip it to B1. You're now connected between B1 and C1. Again, take a reading. Continue in similar fashion until you have bridged every combination and tested at each position. The readings are then analyzed to ensure that they all reflect above 0.5 mega-ohms. If readings are below 0.5 mega-ohms, then the stator may be damp, in which case the windings need to be dried out. Ensure that your report is fully completed and presented to your supervisor. So then, to recap, the electrical test consists of continuity testing and terminal identification, winding insulation to earth testing, where readings must not be lower than 0.5 mega-ohms, and insulation between windings, also not to be lower than 0,5 megaohms. When all checks have proven satisfactory, the motor is deemed safe to use and can be placed back into service. As mentioned, a wet motor will yield low resistance values, below 0,5 megaohms. It is necessary, therefore, to dry out a motor, which we shall briefly overview in the next section.